Everyone, this is a quick video on slant asymptotes. I couldn't find Khan Academy describing slant asymptotes, so I'm gonna have to do it myself. All right, so first let's review where we are with horizontal and slant asymptotes. So we had one condition where the numerator and the denominator are the same degree. All right, and so that's going to be, so if you just think about that, x squared over x squared, those cancel out and that equals 1, right? So we get y equals 1 there. If it happens that there's a coefficient in front, okay, so let's make this again. So we have like 3 over 2 and x squared over x squared. And we cancel that out, we get 3 over 2. So in this case, the horizontal asymptote is y equals 3 over 2. All right. All right. So that's one that we did, which was the same degree. All right. And then we had one where the degree of the denominator had a higher degree. So the denominator had a higher degree. All right, and so if you think about this, when we cancel this, all right, so those are all going to go away, and we're just going to have 1 here, right? So it's going to be 1 over x. Well, what happens when x gets bigger? All right, when x gets very big, when x is very big, like let's make x over 1 million. X over 1 million, 1 millionth. Okay, so as x gets very big, this gets very, very small. Very, very small. And we say it gets closer to 0, so it approaches. So it approaches, this is how I say approaches. It approaches 0. Okay. All right, and so in that case, we would say, so in this case, we said that, y equals, we'll call this, just in case, we have y equals a over b. All right, in this case, it's going to approach 0. All right, so quick review of where we are, because you'll notice then that we don't have one of the, all right, so this one higher degree, it's going to be y approaches 0. Okay, all right. And so we just have one more, which is in the case of what happens when the numerator has a higher degree. What happens then when the numerator has a higher degree? All right, well, if we think about it, when we cancel those out, so this is going to be a 1, that's going to be 1. So it's going to be y equals x. Okay, well, y equals x is like a line like that, right? Kind of a 45-degree angle. It's 1, 1, 5, 5. Okay, and that's not always the case. Okay, and the reason is that sometimes, so that makes a line, but we have to account for, right, your old mx plus b, well, we have to figure out what b is. All right, we have to figure out what b is. All right. So in that case, we have to do long division. All right, there is a shortcut, but let's stick not with the shortcut this time. All right, so I'm going to make up a function here, x squared minus 3x plus 5. Okay, all right, and so to do long division, remember we're looking at, we also talked about that these horizontal I'll write this down. So the horizontal and slant asymptotes, they're not the same as vertical asymptotes, okay? They're a little bit different because they predict end behavior and predict or show end behavior of the function. You know, where vertical asymptotes are like something that the function cannot touch. These horizontal asymptotes show us what's happening out here at the end of the graph, the end behavior, right? So, and in the first two, the end behavior looks like this, right? It's either 0, okay, approaches 0, or it's some line that looks like this, okay? All right, but now with a slant asymptote, we're going to have a line that looks like this. So the end behavior looks like this, okay? All right, and we have to figure out what that line is. So what's the equation of that line? You know, it's an mx plus b. So what's the equation of that line? All right, and that's what we're trying to figure out. All right, so this for a second. And the way we do that, and because we're looking at end behavior, we don't really care about this. We don't care about this. We don't care about this. We only care about the first two terms here of each one. So we don't have to do long division for the whole thing, just for the first two terms. All right, and so that means we're going to do long division. So we're going to do x squared minus 3x, and we're going to divide it into x cubed minus 4x squared. All right, well, so x cubed goes into x, all right? So first we're going to have an x, because x cubed. So if we're dividing x cubed by x squared, we're going to get an x, right? That's x right here. All right, now we're going to multiply. All right, so we're going to multiply x times x squared minus 3x. Remember how our long division works. All right, and this is going to be minus 3x squared. All right, and then we have to subtract that. That's what we do in long division. Okay, so these two cancel out. This becomes a plus, and so we have minus x squared minus 1x squared. Okay, well then, so how many times is x? So we have minus 1x squared. Now we're going to divide it by x squared, and so that's going to equal minus 1. So we're going to have this number right here, minus 1. I know we have a remainder and all that kind of stuff. We don't really care about that. All right, all we care about is this right here. All right, and so there's our y equals, in this case, y equals x minus 1. Okay, so that's what we're doing. So you have to do long division. All right, isn't any fun. Now, I will show you the trick. I don't super like to show tricks because sometimes they're confusing. They don't really help. But I'm going to show it to you. All right, you may have noticed that that this was x, and then the next thing we did was, I can't get this. The next thing we did, all right, maybe it's too far. Next thing we did was we subtracted those. All right, and so you could look at this as negative 4x and then subtracting a minus 3, and that gives you a minus 1. And so there's your x minus 1 right there. And so that's a little shortcut that you might want to use. Okay, so in summary, all right, so when they're the same degree, it's y over the coefficients, which a lot of times is 1 in our problems. When the higher degree is in the numerator, the asymptote is going to be y approaches 0, or y equals 0. And then finally, when it's the higher degree is in the numerator, we're going to have the equation for a line. So y equals x plus b, and you have to find that by doing long division. Okay, I hope that was helpful. And sorry there wasn't a Khan Academy. I'm sure he would have explained it in his Khan Academy.